All right, all these other problems on the next page, definitely worth your time. So yeah, just be careful of the notation. You know, in some cases, what looks like it might be a function of a function, it might be something else. Like here it's function of a function, but here it's product rule. So, you know, you gotta be careful about stuff like that. But definitely worth your time to practice these things. We can dream while he's 9. So number 1 on the next page. These I'm going to go through a little quicker, at least for the easier ones. But then for some of the trickier ones, I'll take it slow and easy. So number 1 is just kind of a reiteration of the Arcsine Rule. We have a constant multiple of 3. And then after that point, we kick into the Arcsine Rule. So u prime over the square root of 1 minus u squared. So here's my u. So 5 over the square root of 1 minus u squared, so 25x squared. You don't have to simplify unless you're expressly asked to. So if a question, I mean, these don't tell you to simplify, so technically you don't have to, but I'm going to do it anyway because you never know. On a test, it might, you know, once or twice ask you to simplify. Just a piece of advice when it comes to the test. If a question asks you to simplify, it's because the answer is simple. All right? So I don't ask you to simplify and then laugh at you when you come up with this monstrous answer that's, haha, it's technically simple. It's just not simple from your perspective. It'll clean up nicely. That's the whole point behind simplifying it. All right? So number 2. No f because it's a y, so I'll write y prime. Arc cosine is the same rule as sine except it's got a negative. So u prime, so it's going to be 6x squared up top, and on the bottom 1 minus that u squared, so 4x to the 6th. All right. The only way to simplify this one would be to just drop the parentheses, which I probably shouldn't have even put in there to begin with. So obviously not something that you would need to worry about. Arc secant, u prime. So 3 over absolute 3x. And then u squared minus 1, so 9x squared minus uno. For number 4, I recommend you rewrite it, or at least consider it slightly differently, as 1/5 of x. This way it's clear what the derivative is going to be, because this is going to be my u, so we're looking at f prime is going to be equal to u prime, so 1/5 up top, 1 plus that expression squared. Let me just actually square it. I was going to put it in parentheses then square it, but kind of a wasted step. Now, this one I'm going to simplify a little bit, not for the purpose of just torturing you, more so for you to be able to see, because we're going to, when we get to trig integrals in a few minutes, you're going to see that some questions are going to be integrals that look an awful lot like the answer to some of these questions. So, bless you. So if you get to a point where you have enough experience differentiating, you say, oh, that's kind of like what I got when I took the derivative of that arctangent function at one time. You already have a sense going into an integral problem of what the answer is going to be. All right. So for this, I want to clear out my denominator. I'm going to multiply top and bottom by 25. So 1/5 multiplied by 25 is going to give me a 5. Here I have to multiply the 1/5 by each part. I'm sorry, the 25 by each part of 1 and 1 plus the 1 over 25 x squared. So 25 plus x squared. All right. So not much in the way of housekeeping, but now I know that if I see the sum of squares in the bottom of a fraction, there's a pretty good chance it's going to be an arctangent. That's the antiderivative. All right. So, I mean, guess and check is not encouraged for this particular unit, but if you start recognizing similarities among different types of derivatives, and you start recognizing what their antiderivatives will look like. I mean, this one's pretty obvious, I think. If I gave you an integral that had an absolute value and a radical in it, if you're not thinking the arcsecant function, then I guess you just don't know the rules. All right, I think it's as simple as that. Number 5, quotient rule. Low d high minus high d low over denominator squared, and away we go. So low, and I need my d high. So the derivative of the numerator is going to be, it's a fraction. My u is 2x, so 2 on the top, square root of 1 minus 4x squared on the bottom, minus the high, which is arcsine of 2x, d low, which is derivative of the denominator, is just a 1, so I'm not even going to write that, over the denominator squared, x squared, and away we go. Not worth simplifying, honestly, because there's nothing really I can do with the arcsine of 2x. Like, I can't simplify that any further, so combining terms, getting common denominators is not going to advance the plot, so we're just going to leave it there. All right, we have a product rule for the next one. H prime first times the derivative of the second. So my u is x squared, so 2x up top, over 1 plus x to the 4th on the bottom, plus the second, arctan of x squared, times the derivative of the first, which, second times the derivative of the first, which is going to be 2x. Same deal. Not worth trying to simplify, because that arctan is there. Now, I have had folks in the past kind of get it in their head that I can simplify an arctangent, or arcsecant, arcsine, arccosine, whatever. I just got to draw that triangle thing. The only time you could simplify an inverse function into an algebraic expression is when it's a function of an inverse function. So if it were like cosine of the arctangent of x squared, then you can make the triangle and do your SOHCAHTOA business. But if it's just a standalone inverse trig function, there's no algebraic conversion for it, or at least not in this coordinate system. Speaking of function, you have a choice in this case. You can go for the triangle approach initially, or you can use chain rule and then do the triangle approach later on. I figure if you got to do a triangle, get it out of the way immediately. Get it into algebraic form first. This is my theta. So theta is equal to arcsine of x, which means that the sine of theta is equal to x. Sine is opposite over hypotenuse. Missing side, square root of 1 minus x squared. Cosine, by definition, is adjacent over hypotenuse. So this over this. So my new p of x, the thing that I would rather take the derivative of would be the square root of 1 minus x squared, or 1 minus x squared to the 1/2. Now, in this case, it actually would be easier to go the other way and use the chain rule on this, but only because the derivative, the derivative of cosine is negative sine, and so those functions are inverses. They cancel out. It would clean up kind of nicely, but it's just one of those things you can't guarantee it. If you rely on that technique every time, you're going to pay a price when it doesn't play out. All right, so you got to get to know the triangle approach, especially when we get to the trig integrals on the next page. Like it's huge. So the derivative, p prime of x, 1/2, 1 minus x squared to the negative 1/2 times negative 2x, which is going to be, when we clean it up, assuming you need to clean it up, ends up being negative x over the square root of 1 minus x squared. 2's cancel out, the negative x stays up top. Because you have a negative 1/2, that radical part is going to go to the bottom. Burning. All right, so another triangle. This part is telling us that tangent of theta is equal to x. Opposite over adjacent, x over 1, square root of 1 plus x squared. Secant is hypotenuse over adjacent. So my new q of x is going to be just the square root of 1 plus x squared, which is the same as saying 1 plus x squared to the 1/2. Much easier to differentiate that, because while in number 7 it would have been all right because derivative of cosine is negative sine, here derivative of secant is secant x tangent x. So what you would have gotten, I'm just going to say it, I'm not going to write it down, you would have gotten secant of arctangent of x times tangent of arctangent of x. And part of it would cancel out cleanly, but you'd still have to draw the triangle to address the secant of arctangent of x. All right, so that one thing that you're trying to avoid, you still have to do it anyway. So you will have completely wasted your time. So q prime 1/2 1 plus x squared to the negative 1/2 times 2x. And then if you needed to clean it up, it would be x over the square root of 1 plus x squared.